In this video, we will learn about friction and its types. Friction. Whenever a body moves or tends to move over the surface of another body, a force comes into play which acts parallel to the surface of contact and opposes the relative motion. This opposing force is called friction. To understand the concept, consider a wooden block placed on a horizontal surface. Give it a gentle push. The block slides through a small distance and then comes to rest. According to Newton's second law, a retarding force must be acting on the block. This opposing force is called friction. Types of frictional forces: static, kinetic, and rolling. Static frictional force. Frictional force acting between the two surfaces in contact which are relatively at rest so as to oppose their relative motion when they tend to move relatively under the effect of any external force is known as static frictional force. Or simply you can say that the force of friction which comes into play between two bodies before one body actually starts moving over the other is called static friction. It is denoted by small f with a subscript s. It is a self-adjusting force and its value lies between its minimum to maximum value. The minimum value of static frictional force is 0 in the condition when the bodies are relatively at rest and no external force is acting to move them relatively. And the maximum value of static frictional force is mu s into n, where mu s is the coefficient of static friction for the given pair of surface and n is the normal reaction acting between the two surfaces in contact. We will study these terms in detail later. Limiting frictional force. The maximum value of static frictional force is the maximum frictional force which can act between the two surfaces in contact and hence it is called the limiting frictional force. In other words, you can say that the maximum force of static friction which comes into play when a body just starts moving over the surface of another body is called limiting friction. And clearly, the static friction will be less than equals to the limiting frictional force. Laws of limiting frictional force. The limiting frictional force depends on the nature of the surfaces in contact and their state of polish. It acts tangential to the two surfaces in contact and in a direction opposite to the direction of motion of body. It is a self-adjusting force. The limiting frictional force is independent of the area of contact between the two surfaces. The limiting frictional force is directly proportional to the normal reaction between the two surfaces, or you can say that the Fs maximum is directly proportional to R, and when you will remove the directly sign, you will get a constant, and that constant is coefficient of static friction. So the coefficient of static friction will be the limiting frictional force Fs maximum divided by the normal reaction N. Kinetic frictional force. The frictional force acting between the two surfaces in contact which are moving relatively so as to oppose their relative motion is known as kinetic frictional force. Its magnitude is almost constant and it is equals to mu k into n. Here mu k is the coefficient of kinetic frictional force for the given pair of surfaces. When the surface will change, obviously its value will change. The kinetic frictional force is always less than the maximum value of static frictional force, or you can say it is always less than the limiting frictional force, because the maximum value of static frictional force is limiting frictional force. So mathematically Fk is equals to mu k into n, and Fk is less than Fs maximum, and Fs maximum is the mathematical notation of limiting frictional force. In the diagram A, impending motion of the body is opposed by static friction. When external force exceeds the maximum limit of static friction, the body begins to move. And in diagram B, once the body is in motion, it is subject to sliding or kinetic friction, which opposes relative motion between the two surfaces in contact. Now, the cause of the friction. There are two theories according to the old theory. The surfaces which appear to be smooth as seen through our naked eyes are actually rough at the microscopic level. And during the contact, the projections of one surface penetrate into the depressions of other and vice versa, due to which the two surfaces in contact form a saw-tooth joint opposing their relative motion. When external force is applied so as to move them relatively, this joint opposes their relative motion. As we go on increasing the external applied force, the opposition of saw-tooth joint also goes on increasing up to the maximum value known as the limiting frictional force, after which the joint suddenly breaks and the surface starts moving relatively. After this, the opposition offered by the saw-tooth joint slightly decreases and comes to rest at almost constant value mu kn, which is known as kinetic frictional force. As shown, according to the modern theory of the cause of the friction is the atomic and molecular forces of attraction between the two surfaces at their actual point of contact. When any body comes in contact with any other body, then due to their roughness at the microscopic level, they come in actual contact at several points. At these points, the atoms and molecules come very close to each other and intermolecular force of attraction start acting between them, which opposes their relative motion. This graph is between the force of friction and the applied force. On the y-axis, there is frictional force and along x-axis, applied force. And this variation of force of friction with applied force shows that As the applied force increases, the static frictional force increases accordingly to balance it. This shows that static friction force is a self-adjusting frictional force. It reaches to the maximum value, means the body is just at the verge of the motion, and then it is denoted by Fs max, or you can say the limiting frictional force. And when the body moves, the kinetic friction force is there and it is slightly less than the limiting frictional force. Thank you.